All right, it's time for some inequality fun. So you guys remember, graphing parabolas. That's one of your favorite things to do. Now, to graph a parabola, we need to find our vertex. We can also find some x-intercepts if we'd like, and another point on the parabola. So let's do some stuff here. So let's first find our vertex using negative b over 2a. So x equals negative b, so negative negative 2 is positive 2 over 2 times a, so 2 times 1 is 2, and this is going to end up equaling 1. So my x-coordinate of the vertex is 1. How do I get my y-coordinate? I plug it back in. 1 squared is 1, minus 2 minus 8, so negative 9. Awesome. So far, so good. We got 1, negative 9. Now my x-intercepts. Well, to get my x-intercepts, I can do some factoring. Let's do that. So AM method multiplies to negative 8 and adds to negative 2. Well, x and x multiplies to negative 8, adds to negative 2. How about negative 4 and positive 2? So that means my x-intercepts are at 4, 0, because I solved that one, and negative 2, 0, after solving this one. All right, let's plot some points here, and then we're going to need one more thing, but we'll plot these points first. So 1, negative 9, right down here, and then 4, 0, and negative 2, 0. And there's one more point that I could use here, because I want 5 total. I'm at 3 now, so I need to get another one. Well, isn't this fancy little thing right here? Isn't that my y-intercept? Boom, plot it. Now, if there's only a way that I could figure out another point, well, how about this? Let's go ahead and put in our axis of symmetry. And when I do that, I can actually reflect. That was kind of a terrible placement there, but I can reflect the y-intercept, that point, over to here. This is an axis of symmetry, right? So it's symmetrical. Okay. So now I've got my 5 points for my parabola. But with an inequality, there's a couple things to consider before we start connecting these dots and making a parabola. We have to take a look at our inequality. Since it's less than or equal to means this is going to be a solid line. Okay. If it was not equal to, we'd be doing a dashed parabola. So solid and dash. The next thing would be shading. Now, to figure out where to shade, we can use some test points. I like to use 0, 0. 0, 0 is really easy to work with. Now, here's how it works. If I plug in 0, 0, that point there, and it works, I'm going to shade where that point is in relation to the graph. So if this point right here works, then I would shade all on the inside, so to speak, of the parabola. If this point doesn't work, I have to shade where this point isn't, meaning out here. So let's see what works. If I plug in the point 0, 0, I'm going to have 0 is less than or equal to, well, 0 minus 0 minus 8. So I'm left with negative 8. Is 0 less than or equal to negative 8? No, that is not true. So that means that I'm going to have to shade on the outside of the parabola. If it were true, say give me a true statement like it was, positive 8 or something, and it said 0 is less than or equal to positive 8, well, then I would shade on the inside. But since it wasn't, I shade on the outside here because it wasn't true with what was in the inside. This point's not true, so I cannot shade in here. No, no, no. Alrighty. And that's all there is to it for graphing these. Not too bad, right? A lot of review. The only difference is solid or dashed for your parabola and where you shade. Those are the only two differences on this type of problem.